inches, and that's what we're given, and we need to find out how many meters this equals, okay? So before we went inches to centimeters as an example, so in this one, again, we're going to write down 18 inches as the numerator over 1 to start out. That's our given. Given is in blue. Then we're going to switch to red, and we're going to get to where we want to be, which is meters eventually. So we said we're going to take 2.54, which is the ratio of centimeters per 1 inch, which is the unit that we were given, okay? Then once we get it to a metric, we're going to switch over and try, once we get to a metric, we're not going to switch it back to a British system, but we're going to go to meters. We're going to stay within the metric, but we're going to get it to another metric unit of measurement. The SI unit, as we remember, is equal to meters when discussing length. So now we're going to say, create the same thing. We're going to create a ratio for what we want. We want a meter, so we're going to put 1 meter is equal to how many centimeters. So we've got to be able to cross-cancel. That's why we're doing this diagonal, why we're creating this numerator to denominator kind of pattern that you see developing here. So 1 meter over how many centimeters? Well, there's 100 centimeters in a meter, as we established earlier in video 1.0 for physics intro. So now, cross-cancel, 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 cross-cancel. What's left? The only unit of measure that's left is meters. So we say 18 inches times 2.54 times 1 is going to give us 0.46. So this equals 0.46 meters. And there is our final answer. Because as we know with multiplication, we're just going to go straight across. Okay, so what it would end up with is needing to divide by this 100, and that's why we moved the decimal to 0.46. That's why the decimal ended up there. So that is a multi-step conversion right there. So like I said, it stays the same. We just keep building out until we get to that last ratio, which is designated with the numerator being the unit of measure that we want. And we just are working diagonally from numerator to denominator until we get to it. It's really just that simple. And a lot of times you'll see people say 18 inches times 2.54 centimeters over 1 inch. And the reason I don't do it this way, even though your physics or your chemistry book's probably going to show it to you this way, is because it doesn't really, in my opinion, it doesn't make as clear why that cross cancel works, because it's 18 inches, which is equivalent to 18 inches over 1. Now we have it's easier to look at, in my opinion, as 2.54 or 1 inch. Why centimeters over 1 inch? Why keep these little tidbits out? Why not just go the extra step and really explain it to the learner so we can see that we can cross cancel there? Because 18 inches is the same as 18 inches over 1. Because anything divided by 1 is itself, and that just gives it to us in a format that makes, again, in my opinion, more sense and just keeps it simpler, and it explains why this is working. If we don't understand why it works, we just have to memorize everything. When you understand why something works, you have to memorize far less, because you can deduce through reason what you need to do in any given situation. And we're going to talk about something real quick. Let's go on a sidetrack about that deductive process. So we talked about fact families, using fact families with formulas, which we'll get into a little bit more in a little while, but what I like to do is I like to take a process to solving a physics problem. Isolate known terms. That's step 1, okay? That's step 1, which you've seen us do so far. Then I like to isolate needed data, which is step 2. So what do they want? What are they looking for? And then from there I like to decide a course of action. Okay, that's step 3. And then I lump in there step 4, of course, solve problem. That's step 4, right? Solve problem. And that's the ultimate end that we're looking for. So isolate known terms, identify needed data, determine course of action, and then, of course, solve. Alright? So before we talked about, what if we were given a velocity equals x, okay, meters per second, right? We're given a distance, which equals y meters, and we need a time. So again, this is really simple, but again, what's nice is we're revisiting some of these formulas, and slowly but surely you're going to have these committed to memory. So, and again, what I put on the whiteboard here, follow along, put that in your notebooks, do it on a scratch paper, it'll help. It's one more approach to committing it to your mind. So, we have velocity and distance. Our fact family says v equals d over t. It also says that t times v equals d. It also says that d divide v equals t. Okay, so we have a fact family, a series of fact family elements here, don't we? So, that's one thing to look at, but isolate known terms. So, it gave us our, let's go back here. We're going to edit and clear. So we're given velocity equals x meters per second. Distance equals y meters. T equals our unknown. So we deduce that from the problem. So we first want to isolate known terms. So that equals velocity equals x meters per second. And distance equals y meters. Isolate needed data. So we're going to put that right here. Our needed data is time. Equals question mark seconds. And then we need to determine the course of action, and that would of course be our fact family situation, right? And we said that v equals d over t, tv equals d, and t equals d over v. So our course of action is we need something that's going to isolate that, right? That isolates time. So this isolates velocity, this isolates distance, and this isolates time. By isolate means we have it all by itself, isolated on one side of the equal sign, right? So this isolated and derived t, right? So here we go. So we're going to say t is going to be equal to x meters per second divided by, whoops, my mistake there, my mistake. T equals meters divided by meters per second. Right? We cross cancel. And all that's left is second, which is a unit of time, so t equals time, right? We got her. So there's our decided a course of action. So there we talked about, so today we talked about conversion factors with a multi-step scenario, right? Scenario, is that right? I hope I spelled that right. Multi-step scenario for conversion factors. And we talked about fact families again right here, right? Physics-based fact families or formula-based fact families. And then we also talked about isolate known terms, isolate needed data, and then determine course of action. 1, 2, 3, and then 4 is solve a 4-step situation, or a 4-step process to solving physics problems. There you go. Ba-boom, ba-boom.